Design this diode circuit to provide an output voltage of 2.4 volts. Let's solve this problem together. First of all, what is meant by design here? It actually just means find a value for R that will make this output voltage the case in the circuit. But this vertical orientation is not something we're used to. So let's redraw this circuit in a way which is a little more familiar to us. This circuit is electrically equivalent to this circuit. You have a DC source of 10 volts feeding the series combination of the resistor R with the 3 diodes. The output voltage is taken across the 3 series diodes. Okay, so let's deal with this redrawn circuit as this is more familiar territory for us. We're told that the output voltage is 2.4 volts, so this means that the voltage of each diode must be 0.8 volts. But the problem also says that each of these diodes has a voltage drop of 0.7 volts at 1 milliampere. So why this discrepancy in the voltage? Well, it's because the 0.7 volts only applies at 1 milliampere, which is not necessarily the current in this circuit. So, does this mean there is an equation relating the current of a diode to its voltage? Yes. There are actually many models that describe the behavior of a forward-biased diode, but the exponential model is the most accurate one. If we substitute 1 milliampere for the current and 0.7 volts for the voltage drop, then we have an equation in IS and VT. IS is the saturation current. Think of it as a parameter for the diode. VT is what we call the thermal voltage, and the equation for VT is KT over Q, where K is Boltzmann's constant, T is the temperature in kelvins, and Q is the magnitude of electronic charge. K and Q are established constants, and let's take T to be 20 degrees Celsius, room temperature. So that'll be 293 kelvins. And if we substitute those constants, we get a thermal voltage of around 25 millivolts. So, substituting this in the equation allows us to solve for IS, the diode parameter, and this is e to the negative 28 milliamperes. You may be wondering, why did I leave it exact like that? What are we, mathematicians? Actually, we're going to use this IS in further calculations, so to avoid any rounding error, I'm going to use this exact form. Okay. Now, we'll use the same equation again, but for a voltage of 0.8 volts. Again, VT is 25 millivolts. 0.8 over 0.025 is 32. And now we can use the value of IS we found earlier, giving us ID equals e to the 4 milliamperes. So this is the current through each diode in this circuit. Remember, the question was to find a value for R, hence designing the circuit. This comes down to the fact that this ID, the current through each of the diodes, is the same as I, the current through the resistor, since it's in series with all diodes. By Ohm's law, we know that this I is the voltage across the resistor, 10 minus VO, over the resistance. VO, remember, was 2.4 volts, and I is this e to the 4 milliamperes we just found. 10 minus 2.4 is 7.6, and we now have a simple equation to solve for R. This works out to be around 139 ohms, so we need a resistance of 139 ohms in series with the 3 diodes to achieve the output voltage of 2.4 volts. And the design is complete.